So I was working on putting this video up on YouTube, and I just realized I sounded like I don't know what I'm talking about. But I do know what I'm talking about, trust me. I just think that video I was just a bit this video I was just a bit, I don't know, out of it. But next video should be better. So yeah, just skip this one. Hi everyone. As we're all stuck within the house, within your home during this unforeseeable event, I would like to share some knowledge with everyone here, as I always do on YouTube. So, today I'm going to talk to you about one of my favorite topics, which is quantum physics. And I wanted to break down quantum physics to anyone, just make it understandable, use the most minimal math as possible. I hope I can. I'm not sure, but I will try my best to just tone it all down so it doesn't feel like I'm speaking in another language. So let's go. So when I think about quantum physics, I think the starting points of it has to be when scientists are trying to find something called black bodies. And black bodies are an idea, that's a concept that scientists has thought of during, I think, around mid-19th century, where they're trying to find the perfect absorber as well as being a perfect emitter at the same time. So an object that's a perfect absorber and a perfect emitter of energy. So the famous Max Planck has found out that the hotter the surface of the object, the more energy of light is going to be emitted. The closest thing to a black body is a star. And as you know, a star is a sun, basically a sun, which emits a lot of light, as there's nuclear fusion happening around it all the time. And he also found out that the hotter the surface of the sun, the more energy of light is going to be emitted. And that makes sense if you think about how if you had a very traditional light bulb and it's emitting a brighter light, you're going to have a more hotter light bulb, whereas if this other light bulb has a dimmer light, it's not going to be as hot as the brighter light bulb. So with that, as we know, light we see around everywhere. It's visible light, and visible light all lies on the same spectrum. So as we here have a spectrum, this is visible light. And here we've got infrared, and we've got radio waves. We've got microwaves, and we've got infrared. And here is visible. This is the spectrum. This is the electromagnetic spectrum. And here we've got ultraviolet and X-ray and gamma. And with that, the hotter the surface, the more energy is going to emit. So here, there's less energy in here as there's a longer wavelength within the left-hand side. And whereas here, these are very short wavelengths. So, as you get more and more energy, the wavelength that the light emits will become shorter and shorter. Not light, the thing emits will be shorter and shorter as there's more and more energy within those particles. And it will slowly shift towards this end over here. So that's basically what a black body does.